Okay. Now with a little refresher on imaginary numbers under your belt, let's move on into parabolas. Parabolas are just the name we give to things, to functions which have an x squared term in there somewhere, and is their largest power of x. So there can be all kinds of stuff here. It can be 3x squared plus 2x plus 1. There can be lower powered single power x terms, and it can be a constant, but the largest power will always be x squared. It may also look like this: x plus 1 squared plus 2. There may be x plus 1. There may be something inside there, not to imply that these are equal. It's just a different one. This is what a parabola looks like. And parabolas always have the form. They're symmetric about their vertex. This is called the vertex. They're symmetric, and sometimes they don't cross the x-axis here. Sometimes they just touch it and have one at one point, and sometimes they cross it at 2 points. So there's either 0, 1, or 2 intersections or x-intercepts of this for a parabola. Now, these are just names we give to this. This is nothing but another function. You can put in numbers and get out, you can put in x values and get out y values, or f of x values. So we give a lot of terminology to this stuff, but don't worry too much about that. It's just another function, and we have some tricks to know what it looks like. It looks like this, opening up, unless there's a negative sign or a negative constant on the front of this. If that's the case, then it opens downwards. Alright, the general form of a function is a x squared plus b x plus c. That's the general form. And we use these constants. These would be just numbers. A, b, and c would be numbers. And you may remember they get used in your quadratic formula, which is a handy formula I don't expect you to remember for finding the roots of these. That's minus b. Don't worry about memorizing these things. And the square root of b squared minus 4ac over 2a. That will give you the two roots, or the intercepts if they're real, and if they're imaginary, then it gives you the imaginary solutions, and the equation never has real zeros. Alright, so this should all be review, but let's take a look at a few of these. You may remember, I think a lot of people's high school math spends a lot of time factoring quadratic equations. It's kind of fun. I think it's fun. Sort of like little Sudoku puzzles. Although sometimes there are no solutions. Let's take a look at one particular function. 3x squared plus 5x minus 2. Alright, again, this is just a function that you put numbers in and you get numbers out. So let's just put some numbers in. You can always find where it crosses the y-axis by putting in 0. If you put in 0 here, you put in 0 for x squared, that becomes 0. 5 times 0, 0 minus 2. So you already have a point, you already have your y-intercept for this equation. Let me write it down here. So it goes through the point 0 minus 2. Well, let's try another point. 1 is pretty easy. 1 equals 3 times 1 squared plus 5 times 1 minus 2. Let's see, that's 3. Plus 5, that's 8. Minus 2 is 6. So it goes through the 1.16. So you already kind of know what this is going to look like. It's going to go like this. And although this is getting steeper and steeper, it never gets too steep, which always kinds of freaks me out. Because it looks like, oops, I made that go through wrong. We have the 1.16. So this is very steep here. I should have maybe drawn at a different scale. So you know it comes up this way. Well, we don't know it turns there. Somewhere down here is the vertex. We don't know where it is. Let's see, at 1 we're already at 6. Let's try minus 1. You can always solve an equation by plotting points. If you plot enough points, you'll get the entire thing. This is 3 minus 1 squared plus 5 times minus 1 minus 2. Minus 1 squared is 1. So this is 3 minus 5. 3 minus 5 is minus 2. Minus 2 again is minus 4. Minus 4. So 1 minus 1. We're actually going down even farther. So that wasn't the vertex here. We know it goes down to here. Just for fun, let's try minus 2. This can get a little tedious. That's why we have all these tricks for finding out what these things look like very quickly. To save you some time. But it's not that tedious here. It's pretty instructive. Let's see, we have minus 2 squared is 4, so this is 12. I'm going to have to write these. Minus 10, minus 2. It turns out to be 0. Well, that's pretty nice. So we know it. This is a point on it here. So we know by symmetry, let's see, it goes somewhere between 0 and 1, and it goes somewhere between 1 and 2, and it's down here at 4. So it's probably going to look like this. We'll revisit this later. So that's a pretty good graph. You've got 3 points on the graph. You got 4 actually. That's a pretty good graph understanding what it is. Well, suppose we wanted to find these 2 points without doing all this. Let me clear this out and write it again. So what we can do is we're going to find the y-intercept. We set this equal to 0 and we find where it crosses the x-axis. Alright, so that's your old skills of factoring these things. You can, if you want, plug it into the quadratic equation and grind it out. That always works. But you can say, well, 3 is a prime number, so it's going to be 3x times x. And we have a minus sign here, so the signs are going to be different. We want 5 in the middle. Let's see, 3 times 2 is 6, and then minus 1 is 5. So if we have the 2 here, the 1 here, we want this to be positive, so this one is going to have to be positive. So these are that's how it factors out. If that's, I mean, if you're a little mystified how I did that, don't worry about it. If you have all kinds of factoring methods, use whatever you're comfortable with. If you don't, just put it into b squared minus 4ac and grind it out. You'll get the same answer. Okay? So this tells us that, what this tells us is we have 2 factors and they multiply out to 0. If 2 numbers multiply out to 0, that means one of the 2 numbers must be 0. That means that either this side equals 0, 3x minus 1 equals 0, which which means x equals 1/3, or x plus 2 equals 0, which means that x equals -2. And these are our two x-intercepts. So it goes through, I'm going to write a big scale here. This is 1, it's -1, -2. So we know it goes through 1/3, about there, and it goes through 2. So let's see, the vertex is going to be a little bit over there. This is positive, so it opens upwards. So our parabola looks something like this. We should find that point where it crosses here, and pretty clearly from looking at that, it should have been a lot farther down. Unless I say, well, the scale is different here, which I can do. A little bit of cheating. Alright, so that's how that works. Sometimes you won't be able to factor these. I'm going to show you a couple more really quickly. This is all just helping you graph and understand where parabolas were, what happens on what parabolas. A lot of times we're interested in where parabolas are 0. Those are the solutions. Let's look at another one really quick. What if we had f of x equals to x squared plus, let's make it minus 4x. I have a little flashing light telling me I've run over 10 minutes. I try to keep these under 10 minutes. Oh, this one, let's see. How about this? Let's see, does this factor? Let's see, 4 is 2 times 2, so if we have -2 and -2, that would add up to -4 in the middle, and -2 times -2 is +4. So we get this. These two are the same. You could also write this as x minus 2 squared. This only has one zero. It happens when x equals 2. So this parabola just touches a 2. It has 1, 0. Sort of a degenerate case where the two come together. Where is the cross up here? 1, 2, 3, 4. You can see that if you put in x equals 0, you'll get f of x equals 4. So this one looks like this. Again, it's pretty easy to factor that. If you didn't like doing that, you can go to b squared minus 4a squared. You can use the quadratic equation to solve that. Alright. Sometimes, I'll do one other example. X squared plus x. Sometimes it's hard to tell if these factor easily. This one looks like it factors easily. So this has to be, x is here. 2 only has 2 and 1. Let's see. This is positive. This is positive. So these either are both negative. No, this is not going to work. We cannot look at that and factor. We can use minus b plus or minus square root b squared minus 4ac over 2a to get our two roots, to get our two x values where this is 0. In this case, a equals 1, b equals 1, and c equals 2. So putting those numbers in, this is minus 1 plus or minus square root of b squared, 1 squared, 1, minus 4 times 2 times 1, 4ac. 4 times 2 is 8, times 1 is 8, over 2a. a is 1, so this is over 2. Let's simplify that a bit. 1 minus 8 is minus 7. And there are our roots. We have a negative 7 inside here. So that tells us our roots are going to be complex. They're going to have an imaginary number in them. We can rewrite this if we want as minus 1 plus or minus square root of 7i. The I is outside the square root. Over 2. Those are our roots. What that kind of means is this parabola, wherever it's located, we're not sure. It does open up because that's positive x squared. It doesn't cross the axis. It crosses in some imaginary, and now I'm drawing this line magically out of the screen. It crosses in some imaginary axis there. As that goes down like that. It's something rarely people, math classes tell you about, this sort of imaginary part of the parabola that lives in the imaginary realm. Okay. So that's finding the x and y axis intercepts of a parabola. Nothing you haven't done before. Next, again, these are just shortcuts for finding properties of parabolas, and parabolas are just functions with an x squared term in them as the highest power of x. Next thing, we'll find out where this point is that it changes, this vertex is. We'll leave that for next time. Alright, but already with the x and y intercepts, we have a lot of information on our parabola.